February 14th, 1944. RAF Woodbridge, Suffolk, England, 0347 hours. The sound came first, a sharp metallic crack that cut through the idling engines and pre-dawn conversations, then silence, then shouting. Technical Sergeant William Moss stood 30 yards from the B-24 Liberator when its port wing folded upward like a closing book. The aircraft hadn't moved. The engines weren't running hot. No flak damage, no combat stress. The bomber had simply been sitting on the hardstand, fueled and loaded for the morning mission to Schweinfurt, when the main spar gave way. The wingtip touched the fuselage. Metal screamed. Fuel began pooling beneath the nacelles. Moss didn't run toward it. He'd seen this before, twice in January, once in late December, always the same. Catastrophic structural failure with no external cause. Always Liberators, always the wings. Ground crews swarmed the aircraft. Fire suppression teams deployed foam. The pilot, still in the cockpit running pre-flight checks, climbed out through the top hatch, face pale in the work lights. Behind Moss, someone muttered a prayer. He turned and walked toward the maintenance hangar, hands shoved deep into his coat pockets, breath-forming clouds in the frozen air. His boots crunched over frost-hardened gravel. Around him, the airfield continued its pre-mission rhythm. Fuel trucks, ordnance carriers, men shouting grid coordinates and weather updates. But Moss wasn't hearing any of it. He was thinking about wood. William Moss had been a carpenter in Spokane, Washington before the war. He'd built houses, barns, fishing boats. He understood grain structure, load distribution, and the way materials failed under stress. When the Army Air Forces discovered he could read technical drawings, they'd made him a structures specialist and shipped him to England. For 8 months, he'd been patching aluminum, replacing rivets, and signing off on airworthiness inspections. Standard work. Predictable failures. Combat damage he could see and fix. But this was different. The B-24 Liberator was a workhorse, longer range than the B-17, higher payload capacity, faster cruise speed. But it had a reputation. Pilots called it the flying coffin. Not because it caught fire easily, though it did. Not because it was hard to bail out of, though it was. They called it that because of the wings. The Liberator's wing was a marvel of engineering, thin, high aspect ratio, built for efficiency and range. But thin wings meant less internal structure, less redundancy, and when they failed completely. Moss had read the incident reports. He'd seen the photographs from other air bases. Wings folding in flight, wings collapsing during landing, wings buckling under asymmetric fuel loads. The official explanation was always the same: material fatigue, combat damage, or pilot error. But Moss knew better. He reached the maintenance hangar and pushed through the side door. Inside, the space smelled of oil, solder, and paint thinner. Work lights hung from the ceiling beams. 2 mechanics were rebuilding a Wright Cyclone engine on a stand in the corner. Moss walked past them to the technical library, a closet-sized room lined with manuals, blueprints, and engineering specifications. He pulled the B-24 structural manual from the shelf and spread it across the work table. He'd studied this document a dozen times. He knew the wing spar layout by heart, knew the stress points, knew the load limits. But something was missing. The manual showed the primary structure, the main spar running span-wise through the wing, carrying the primary bending loads. It showed the ribs, spaced every 20 inches, giving the wing its aerodynamic shape. It showed the skin, riveted to the framework, carrying shear loads. What it didn't show was how those components worked together under real-world conditions. In a perfect world, loads distributed evenly, forces transferred smoothly from skin to rib to spar. But the world wasn't perfect, especially not at 25,000 feet, in sub-zero temperatures, with flak holes and bullet damage and ice accumulation and asymmetric thrust. Moss flipped to the section on wing spar specifications. The main spar was a massive I-beam, machined from aluminum alloy, running from root to tip, strong in pure bending, but vulnerable to torsional stress, twisting forces. And that, Moss realized, was the problem. The B-24's wing was so thin and so lightly built that it flexed constantly in flight. Every gust of turbulence, every throttle adjustment, every bomb release, the wing twisted slightly, and that twisting motion concentrated stress at specific points along the spar. Over time, those stress concentrations caused microscopic cracks. The cracks grew, and eventually, without warning, the spar failed. It wasn't a design flaw, exactly. It was a trade-off. The engineers at Consolidated Aircraft had prioritized range and payload over structural margin. They'd assumed the wings would hold up under normal use, but there was nothing normal about flying combat missions over Germany. Moss closed the manual and stared at the wall. He couldn't fix the wing's fundamental design. He couldn't add more material to the spar without rebuilding the entire aircraft. He couldn't change the mission profiles or reduce the payload weights. But maybe, just maybe, he could stop the twisting. February 15th, 1944, RAF Woodbridge, 11:20 hours. Moss stood in the salvage yard, surrounded by wreckage. The yard occupied a muddy acre at the airfield's northeast corner, where damaged aircraft were stripped for parts before being scrapped. Twisted aluminum, shattered plexiglass, engines with cracked casings, fuselage sections with jagged holes, and wings. Moss had requested access to every B-24 wing failure on record at Woodbridge. The salvage officer, a bored lieutenant from Indiana, had shrugged and waved him in. "Help yourself, Sergeant. Most of it's headed for the smelter anyway." Now Moss moved slowly through the debris field, examining each wing section. He carried a small notebook, a flashlight, and a carpenter's folding rule. The first wing belonged to a Liberator that had crashed on approach in December. The port wing had folded upward during final descent, causing the aircraft to roll inverted and impact short of the runway. Crew lost. Moss crouched beside the wreckage. The wing was in 3 pieces, separated at the failure points. He ran his gloved hand along the exposed spar. The fracture surface was rough, crystalline, classic fatigue failure. The crack had started small, at a rivet hole near the outboard fuel tank, and propagated slowly across the spar's lower flange. When the remaining material could no longer carry the load, it had failed catastrophically. Moss measured the distance from the wing root to the failure point. 83 inches. He noted it in his book. The second wing came from a Liberator that had broken apart over the North Sea in January. The aircraft had been returning from a mission to Hanover, severely damaged by flak, when both wings folded simultaneously at altitude. No survivors, only fragments recovered. The spar fracture was identical. Same location, roughly 80 inches from the root. Same fatigue pattern. The third wing, the fourth, the fifth. Every single failure occurred between 75 and 90 inches from the wing root. Moss stood and looked across the salvage yard. The pattern was undeniable. But why that specific location? He pulled the structural manual from his coat and flipped to the wing station diagram. Station 80 corresponded to the outboard edge of the fuselage, the point where the wing transitioned from the enclosed center section to the free cantilevered outer panels. It was a load concentration point. All the aerodynamic forces from the outer wing, lift, drag, torsion, funneled through this single station before transferring into the fuselage, and it was exactly where the wing twisted most. Moss closed his eyes and visualized the problem. Imagine the wing as a long beam, anchored at one end. Apply a twisting force to the free end, say, from a gust of wind hitting the wingtip. The beam rotates slightly. The material near the anchor point experiences maximum shear stress. Now imagine that beam is hollow, thin-walled, built for minimum weight. The twisting motion concentrates at the anchor point, and the thin walls begin to buckle. Add fatigue, add vibration, add thermal cycling from 50 degrees at altitude to plus 160 degrees on the ground. The material doesn't break suddenly. It breaks slowly, one flight at a time, until the final mission when the accumulated damage exceeds the remaining strength. That's what was happening to the liberators. Moss opened his eyes. The solution wasn't to strengthen the spar itself. That would require a complete redesign. The solution was to prevent the twisting motion from concentrating at Station 80. He needed to stiffen the wing torsionally without adding significant weight. He needed something that could be retrofitted to existing aircraft without major disassembly. He needed a brace. Moss returned to the maintenance hangar and cleared a space at the work table. He spread out the wing blueprints and began sketching. The brace would run diagonally across the interior wing structure, from the spar to the rear bulkhead at Station 80. It would act like a triangular truss, preventing the spar from rotating relative to the rest of the wing. But it couldn't be solid aluminum. That would be too heavy and too difficult to install. It needed to be strong in tension and compression, but light. It needed to fit around existing fuel lines, control cables, and hydraulic runs. Moss stared at his sketch. Then he smiled. Wood. Wood was strong, lightweight, and easy to shape. It could be cut to fit irregular spaces. It could be bolted directly to existing structure without welding or riveting. And it had excellent resistance to fatigue. Wood fibers bent and flexed without cracking the way metal did. It was, he realized, exactly the wrong material by every official standard. The Army Air Forces didn't use wood in primary structures. Wood burned. Wood rotted. Wood absorbed moisture and changed dimensions. But it would work. Moss began calculating dimensions. The brace needed to be about 60 inches long, running from the spar to the rear bulkhead at a 45-degree angle. It needed to be at least 2 inches thick and 4 inches wide to carry the loads. He'd use laminated ash, multiple thin layers glued together, oriented to maximize strength. Ash was what he'd used for tool handles and ladder rails back in Spokane. Tough, resilient, available. The attachment points would be aluminum brackets, bolted through existing holes in the spar and bulkhead. No new holes, no modifications to the primary structure. He could build the prototype in 2 days, install it in 3 hours, test it immediately. If it worked, he could retrofit every B-24 on the base in a month. If it didn't work, well, at least he'd tried. Moss folded the blueprints and headed for the door. Outside, the February sky was low and grey. Another mission was forming up overhead, dozens of bombers assembling into combat boxes, climbing toward Germany. He watched them for a moment, thinking about all the pilots who didn't know their wings were slowly breaking. Then he went to find Wood. February 17th, 1944. RAF Woodbridge. 0630 hours. The prototype lay on the hangar floor, surrounded by sawdust and wood shavings. Moss had worked through the night, using hand tools borrowed from the base carpenter's shop. No power saws, they were too loud, and he didn't want to attract attention until he had something worth showing. The brace was elegant in its simplicity, 62 inches long, 3 inches thick, 4.5 inches wide. 5 layers of ash, each 1/4 inch thick, laminated with waterproof resorcinol adhesive. The grain oriented at alternating 45-degree angles for maximum strength. At each end, aluminum brackets. Moss had fabricated them from scrap sheet metal, using a handbrake to form the angles and a drill press to place the bolt holes precisely. The entire assembly weighed 11 pounds. Moss picked it up and flexed it. Solid. No movement. The lamination process had created a composite structure stronger than the individual layers, similar to the plywood he'd used for boat hulls before the war. Now came the hard part. He needed permission to install it. Officially, any modification to an aircraft required approval from the engineering division at Wright Field, Ohio. The approval process took weeks, sometimes months. Forms had to be submitted, calculations reviewed, prototypes tested in controlled conditions. Moss didn't have weeks. Yesterday, another Liberator had developed a spar crack during post-flight inspection. The crack was only 6 inches long, barely visible, but it was growing. The aircraft had been grounded pending evaluation. 3 days ago, a crew had reported unusual vibration in the port wing during a mission to Brunswick. Inspection revealed nothing, but the pilot refused to fly the aircraft again. The failures were accelerating. Moss wrapped the brace in canvas and carried it across the airfield to the engineering section offices. The morning was cold and clear. His breath formed thick clouds. Frost covered the grass. Inside the office, he found Captain Harold Vickers, the senior engineering officer, sitting at a desk piled with technical orders and maintenance reports. Vickers was a pre-war aeronautical engineer from Boeing, precise and methodical. He'd approved every modification Moss had proposed in the past 8 months, but always with documentation, testing, and proper authorization. Moss set the wrapped bundle on the desk. "Captain, I need to talk to you about the wing failures." Vickers looked up from his paperwork. "We're aware of the issue, Sergeant. Wright Field is reviewing the data. We should have guidance in 2 to 3 weeks." "We don't have 2 weeks, sir." Moss unwrapped the brace and laid it on the desk. Vickers stared at it. "What is that?" "A torsional stiffener. Installs at Wing Station 80, diagonal from the main spar to the rear bulkhead. Prevents the wing from twisting under asymmetric loads. It's made of wood." "Yes, sir." "Sergeant, we don't put wood in bomber wings." "I know, sir, but this will work." Moss spread his sketches and calculations across the desk. He explained the failure pattern, the stress concentration at Station 80, the torsional buckling mechanism, the need for a retrofit solution that didn't require major disassembly. Vickers listened without interrupting. His expression remained neutral. When Moss finished, the captain leaned back in his chair and studied the brace. "Or even if this works," Vickers said slowly, "I can't authorize an unapproved modification to combat aircraft. If something goes wrong, if an aircraft crashes because of your brace, I'll be court-martialed. You'll be court-martialed, and every crew member will be dead." "Sir, aircraft are already crashing because of the existing design. That's Consolidated's problem, not ours." Moss felt frustration rising but kept his voice level. "With respect, Captain, Consolidated isn't here. We are. And we have Liberators falling out of the sky because the wings are breaking." Vickers was silent for a long moment. Then he stood, walked to the window, and looked out at the flight line. "How long to install one?" 3 hours, maybe 4. "And you're certain it won't interfere with fuel systems, flight controls, or hydraulics?" "I've checked the clearances. It fits." Vickers turned back. "Here's what we're going to do. You'll install your brace in one aircraft. We'll run ground tests, control deflections, fuel flow, structural load tests. If it passes, we'll do one flight test. Local area only, no combat mission." "Yes, sir." "If anything fails during testing, we stop immediately." "Understood." "Understood." Vickers picked up the brace and examined it closely. "You built this yourself?" "Yes, sir. It's good work." "Thank you, sir." "Don't thank me yet, Sergeant. If this goes wrong, we're both finished." Moss chose the aircraft carefully. Serial number 42-52163, a B-24H that had flown 19 missions and accumulated 280 flight hours. Moderate flak damage, all repaired. No unusual maintenance history, assigned to the 392nd Bomb Group. Crew commanded by Lieutenant Donald Parker. The aircraft was scheduled for a test flight the following morning after routine maintenance. Perfect timing. Moss assembled a 3-man team, 2 sheet metal mechanics and an inspector. He briefed them in the hangar, showing them the installation drawings and explaining the procedure. The work began at 1400 hours. They jacked the aircraft and opened the lower wing access panels at Station 80. Moss climbed inside with a flashlight. The interior wing structure was a maze of spars, ribs, stringers, fuel lines, control cables, and hydraulic lines. Everything coated with a thin film of oil and dust, barely enough room to move. Moss measured twice, marking the attachment points with a grease pencil. The forward bracket would bolt to the spar web using existing holes. The aft bracket would attach to the rear bulkhead, also using existing holes. No drilling, no cutting. He positioned the brace and held it in place while one mechanic passed bolts through from the outside. The fit was tight, exactly as calculated. The wood pressed firmly against the surrounding structure without gaps. They torqued the bolts to specification. Moss tugged on the brace. Solid. He backed out of the wing and inspected the external attachment points. Clean installation, no interference with skin panels. They repeated the process on the starboard wing. 2 hours, 40 minutes total. When they finished, Moss stood back and looked at the aircraft. From the outside, nothing had changed. The modifications were completely invisible. Inside, the wings were now significantly stiffer. He signed off on the installation paperwork and walked back to engineering section. Captain Vickers was waiting. "Done?" he asked. "Done, sir." "Then let's see if it works." February 18th, 1944. RAF Woodbridge, 0815 hours. Lieutenant Donald Parker stood beside the Liberator, arms crossed, staring up at the port wing. "You put wood in my airplane?" Moss nodded. "Yes, sir." "Wood?" "Yes, sir. Laminated ash, high strength, low weight, designed to prevent torsional buckling of the main spar." Parker was 24 years old, a pilot from Nebraska with 17 combat missions and a reputation for asking difficult questions. His crew trusted him because he was careful, methodical. He didn't take unnecessary risks. And this has been tested. How? "Ground tests completed yesterday evening, sir. Control deflections normal. Fuel flow normal. Structural load test showed a 38% increase in torsional stiffness." "That sounds like you made the wing more rigid." "Correct, sir. Which means it might not flex the way it's supposed to. Which means it might break somewhere else." Moss had anticipated this. "The brace prevents excessive twisting, but it doesn't eliminate normal bending. The wing will still flex vertically in response to gusts and maneuvers. It just won't twist as much." Parker looked at him for a long moment, then at Captain Vickers, who stood a few yards away. "Captain, are you ordering me to fly this aircraft?" Vickers shook his head. "No, this is a voluntary test flight. If you're uncomfortable, we'll find another crew." Parker turned back to the Liberator. He walked slowly around the nose, inspecting the wings, the engines, the landing gear. His flight engineer, a technical sergeant from Michigan, climbed up to the cockpit and began pre-flight checks. After 5 minutes, Parker returned. "What's the test profile?" Moss pulled a folded card from his pocket. "Local area flight. Climb to 10,000 feet. Perform standard maneuvers. Level flight, turns, climbs, descents. Then a series of control inputs to induce wing flex. Aileron rolls, coordinated turns, simulated evasive action. Total flight time 1 hour. No bomb load." "No, sir. Just fuel. And if I feel anything unusual, any vibration, any control issues, I abort immediately." "Absolutely, sir." Parker nodded slowly. "All right. Let's see what your wood can do." The pre-flight took 30 minutes. Moss watched from the hardstand as the crew boarded. 8 men: pilot, co-pilot, engineer, navigator, bombardier, radio operator, and 2 gunners. Engines 1 and 2 started with the usual coughing roar, then 3 and 4. The propellers synchronized into a smooth thunder. Parker advanced the throttles slightly and released the brakes. The Liberator rolled forward, turning onto the taxiway. Moss climbed into a jeep with Captain Vickers and a flight surgeon. They drove to the control tower and climbed to the observation deck. The airfield spread below them, runways, hard stands, hangars. Beyond, the flat farmland of Suffolk stretched toward the coast. The Liberator lined up on runway 24. Parker ran the engines up to full power, checking magnetos and propeller governors. Brakes released. The bomber accelerated slowly, heavily, even without a combat load. 30 knots, 50, 70. The tail lifted. The wings flexed upward slightly under the increasing lift. At 90 knots, Parker rotated. The nose lifted. The main gear left the pavement. The Liberator climbed away, gear retracting, flaps coming up. Moss watched until it was just a speck against the clouds. Now they waited. Inside the wing, the brace was doing its job. Every time Parker banked the aircraft, the ailerons deflected, creating asymmetric lift. The wings tried to twist, one rising, one falling, but the diagonal braces resisted that motion, forcing the load to distribute more evenly along the spar. At altitude, Parker performed a series of test maneuvers, steep turns, 45 degrees of bank, pulling 2 Gs. The wings flexed upward under the increased load, but without the dangerous twisting motion. Aileron rolls, full deflection, rapid rotation. The wings bent and twisted slightly, but the spar remained well within its design limits. Simulated evasive action, aggressive pitch and yaw inputs, as if dodging flak. The airframe shuddered, but the structure held. In the cockpit, Parker felt the difference immediately. The aircraft felt stiffer, more solid. The wings didn't have that disturbing flexibility he'd noticed on previous flights, the sensation that the wingtips were moving independently of the fuselage. He keyed the intercom. "Engineer, any unusual vibrations?" "Negative, sir. Engines normal. Structures normal." "Co-pilot, controls feel good. Maybe a little heavier in roll, but nothing significant." Parker leveled off at 10,000 feet and flew a wide circle around the airfield. He looked out at the port wing. It looked the same, moved the same, but somehow it felt more trustworthy. He made his decision. "Woodbridge Tower. This is Army 2163, requesting landing clearance." 2163, cleared to land runway 24. Winds light and variable. Parker descended and entered the pattern. Gear down, flaps down. He trimmed for approach speed and lined up on final. The runway stretched ahead, grey concrete against brown fields. He crossed the threshold at 90 knots and eased the throttles back. The main gear touched smoothly. He held the nose high, aerodynamic braking, then lowered it gently to the pavement. They rolled out and turned off at the first taxiway. Parker shut down the engines and sat in silence for a moment. His engineer leaned forward. "Sir?" "It worked," Parker said quietly. "Whatever they did, it worked." On the observation deck, Moss allowed himself a breath he didn't realize he'd been holding. Captain Vickers lowered his binoculars. "Well, Sergeant, your wood didn't kill anybody." "No, sir." "Now we have to prove it'll save somebody." March 1944 to June 1944. RAF Woodbridge and multiple Allied air bases. The formal report reached Wright Field on March 3rd. Captain Vickers had documented everything: the failure analysis, the design rationale, the installation procedure, the test results. He'd included stress calculations, photographs, and a written endorsement from Lieutenant Parker. The response came back in 4 days. Approved for immediate implementation. All B-24 units, European Theatre of Operations. The modification was designated Field Change 471 and classified as mandatory, airworthiness critical. Every Liberator in England would be retrofitted within 60 days. Moss built the first production run himself. He set up a workshop in a corner of the maintenance hangar and trained 6 carpenters, men who'd been building crates and repairing wooden structures around the airbase. They worked in shifts, laminating ash, cutting braces to length, fabricating brackets. Each brace took 4 hours to build. Each installation took 3 hours. The work spread quickly. Within 2 weeks, every B-24 at Woodbridge had been modified. Within 4 weeks, the 392nd Bomb Group was complete. By May, the modification had been implemented at every 8th Air Force base in England. Then the reports started coming back. A Liberator from the 93rd Bomb Group took heavy flak damage over Augsburg, 23 holes in the port wing, including 2 that penetrated the main spar. The aircraft returned to base. Inspection revealed no spar crack propagation. Without the brace, the pilot reported, the wing would have failed. A crew from the 44th Bomb Group experienced severe turbulence during a mission to Berlin. The aircraft dropped 3,000 feet in 10 seconds, pulling negative G-forces that would normally cause structural damage. Post-flight inspection showed minor skin buckling, but no spar damage. A formation of 6 Liberators was caught in a storm over the North Sea. 3 aircraft sustained lightning strikes. All landed safely. Previous experience suggested at least one would have suffered wing failure. By June, the failure rate had dropped to near zero. No more wings folding on the ground, no more catastrophic in-flight failures, no more crews lost to structural problems. The modification worked, but the official recognition came slowly. Wright Field issued a technical bulletin crediting improved maintenance procedures for the reduction in wing failures. No mention of Moss, no mention of the wooden braces. The Army Air Forces didn't want to publicize the fact that a field modification designed by a Carpenter, built without authorization, using a non-standard material, had solved a problem their engineers had missed. Moss didn't care. He'd saved lives. That was enough. In late June, he received a letter from the engineering division. They wanted him to report to Wright Field for a temporary assignment, helping design retrofit modifications for other aircraft types. He declined. His place was in the field, with the crews, where he could see the problems firsthand and fix them before they killed anybody. Captain Vickers submitted paperwork recommending Moss for the Legion of Merit. The recommendation was downgraded to a commendation medal, then quietly filed away. But the crews knew. In the months that followed, Moss received dozens of informal thank yous, notes left on his workbench, bottles of whiskey hidden in his tool locker, handshakes from pilots he'd never met. One morning in August, he found a message chalked on the side of his toolbox. "To the carpenter who fixed our wings, we owe you." No signature. By the end of the war, more than 600 B-24 Liberators had been retrofitted with the wooden torsional braces, thousands of missions flown, tens of thousands of sorties, 0 wing failures attributed to torsional buckling. The modification remained in place through the end of the war. When the aircraft were eventually scrapped, the braces were removed and discarded. No samples were preserved. No official recognition was recorded in the final engineering reports. The innovation simply faded into the noise of wartime logistics. William Moss returned to Spokane in November 1945. He resumed his carpentry business, building houses and fishing boats, never speaking publicly about his time in England. In 1963, a researcher at Boeing discovered a reference to Field Change 471 while reviewing wartime engineering documents. He attempted to locate the original designer, but found no records. The modification had been implemented, used extensively, and then forgotten. The researcher wrote a brief article for an internal engineering journal, noting that the solution to a critical structural problem had come not from a team of specialists with advanced degrees, but from a single technical sergeant who understood wood better than aluminum. The article was never published outside Boeing. Moss passed away in 1979. His obituary in the Spokane newspaper mentioned his military service, but included no details. His tools, including the folding rule he'd used to measure the first brace, were donated to a local historical society. They remained in storage, uncatalogued, until 2003. The wooden braces themselves are gone, burned, buried, or rotted away in salvage yards across Europe. But somewhere in the archives at Wright-Patterson Air Force Base, there is a technical order dated March 1944. Field change 471. Mandatory installation. Approved for emergency implementation. 23 pages. Diagrams, specifications, installation procedures, and on the final page, in faded typewriter text, designed by TSEK William J. Moss, RAF Woodbridge, February 1944. No award, no ceremony, no recognition, just the quiet notation that one Carpenter's idea had kept 600 aircraft flying and brought their crews home safely. In the end, that was all that mattered.